Thank you very much. Uh, Bismillahirrahmanirrahim. So let us start. So today, this is week number 2, and we shall be learning about data representation in AI fundamentals. And I also want to dedicate this lecture to this guy, and we will be learning about him in a while. So this is what we did in our first lecture. We defined AI. So I use a definition, and I mentioned that I'll be keep coming back to this definition, and we will again revisit that before learning about the data representation. Then we spent time learning about latest trends and potential, and I also gave you an assignment which was about the latent trend in 2023 Gartner hype cycle, and I asked you to write a short paragraph about each trend. And then I also gave you an example of how AI works, and then we also have a philosophical discussion that if AI is going to do everything, then what will happen then to so many other professions. And then we learned about the AI algorithm, classification, regression, generative AI. And I was just giving you my personal background in AI. And then we had to just stop because of some technical problems. So we will just start from here. आपने कहीं बैठना तो बैठ जाओ इधर कोई खड़े हाँ. So we'll start from here today. And so this is what I intend to do. My background, I'll keep covering my personal background in AI and the course outline. So there is a PDF which lists all the topics. So I'm not going to cover that, but I will broadly tell you like this is what we are going to learn in this course. So today is about data representation. That, as we mentioned, that data representation is core to artificial intelligence because computers cannot hear, they cannot feel, they cannot see. So you got to make them hear, feel, and see. So how do you do that? How do you represent data to feed to an AI model? So this is what we are going to learn. And then once we go to AI fundamentals, what are the prerequisites? What knowledge do we need to have to learn AI? So linear algebra comes at the top. And we will shortly find out that why linear algebra is important to learn for artificial intelligence. So is the probability and statistics. So we need to learn about that too. And then Python, enough to generate code. So today we are going to have assignments where I'll ask you to generate code. So whatever we are learning, we are going to go back and we are going to generate Python code. And we are going to just run it so that we get a grip on the concepts, and more importantly, just getting this ease that, oh, I can also code, whether you are a coder or not. So that ease is very important, that you say, oh, it's so simple to code something in Python. So this is what we are going to experiment today. And then I'll give you a startup idea. So one of the objectives of this course is that you should able to start or initiate your own startups in AI. Because once you have this comfort that code can be generated, and once you understand the entire spectrum of AI, so then the creativity becomes central, that if you have a creative mind and you can think about something which has commercial potential or which can impact something socially, so those are the things that I would like to do. So let's go to the first topic, which is my background. So I thought about doing this with relevant topics. So whenever we are studying a relevant topic, I'll tell you that what I have done in that, and especially with my PhD students or MS students, mostly PhD students work. So I'll be highlighting that what was the thought behind a specific PhD thesis and how we accomplished it, how we published. So I'll be telling you that, or sometimes the project we did in CARE. So what was the, again, motivation of incorporating AI in a specific commercial or technology, a project. So AI always augment. AI itself is not a product. This is something very important we need to learn. It's not a product. It's just an enabler. So you enable something with AI. Okay, and it's rethinking, as I said. So if I can make you rethink in terms of AI, that will be kind of success of the course. So I told you about my first publication was on artificial intelligence, and that also helped me to understand, because I implemented the algorithm on a parallel machine. So this helped me to understand the intricacies of a backpropagation neural networks or neural networks, which has now taken over. So in 1995, I actually implemented it on an array of processors, and that was actually the way to go. Now we see that was the way to go. Now all the GPUs and TPUs, and that's all they do. That I did in 1995, and had an exposure of how to parallelize an algorithm, how to partition the data, how to make every processor do something useful, how to have maximum utilization, processor utilization. So I also mentioned that people were very skeptical about AI, and the topic of the conference was, are neural networks dead? Because people thought the type of computation it requires and type of data it requires. The computational power at that time was not with everyone. So it was not on a desktop, for example. So people thought that it's not going to work out. And so we shall also be covering the ups and downs of AI once we track history. But I have also been involved, and that's why I want policy to be part of this course. I have been involved in crafting national policy for AI, and it was actually January of 2019, 29 January. This meeting was held with the Prime Minister chairing the meeting, and there are many characters what you see in this picture. Asad Umar is sitting, Azam Khan. So and today we know many of them for reasons. So Imran Khan is sitting here, I'm sitting here, and Benori Saab is sitting here, Dr. Atta. So this is the time like we got a blank check from the Prime Minister to take Pakistan towards knowledge economy, knowledge-based economy. Wanted Pakistan to move towards knowledge-based economy, and formulated 3 task forces. And I was interestingly part of all the 3 task forces: task force on knowledge economy, on IT and telecommunication, and science and technology. And I was very closely working with Dr. Atta. That enabled me to develop so many programs, to develop a national strategy that how should we take Pakistan to move towards AI. So this is a strategy. I'll not discuss it today, but I would definitely come back once we start discussing strategies. So I'll come and discuss the strategy we made for the country, that this is what we are going to do for Pakistan. What are the infrastructure requirements? So it goes from base down to up, having infrastructure, national cloud, data centers, different entities which got to put in place, and then how to kick the startup ecosystem, how to have a team which is developing national industry team which is developing all the AI algorithms, and so it was very, very interesting strategy. And based on the strategy, then we started developing many programs. And the most important of them was National Centers for Research, Innovation and Entrepreneurship in AI and Allied Technology. So that was the most exciting, that we were going to have a center in Islamabad, in Karachi, in Lahore, in Peshawar, and in Quetta. And then we were also working on Prime Minister University, which was just focusing on AI. And then we had 21 other initiatives. And one which I was really very proud of was getting this passed through all the channels of the government, which was scholarships for training top human resource in world top 100 universities. So there were about 600 scholarships focusing on AI, so that we train our HR. So at every level, we were planning to train HR, and so that we become a significant country in artificial intelligence. But so nothing happened, so that's why I'm doing this course. At least we can perhaps add some value by just at least teaching AI to people. So this is the course outline and learning outcome. So So we first objective is that we learn artificial intelligence and exploring the state of art. So that's important. That state of art. What is the state of art? Where it stands today? What is the frontier? And we've got to look at this is the frontier of AI. So we are going to do that, and because we are going to build it ground up, so we will cover all the concepts. But we'll keep touching. It's not that you only learn the basics in a class. Always in every lecture you are going to learn what is the latest. Okay. So so then the other thing which I want you to have is like you rethink. So mind should just rethink in terms of AI. That's the goal. That end of the course you should able to just rethink anything you do and how you can incorporate AI in it. Okay, theoretically. So one is like you rethink, but thinking is like you can think anything. But the important is what you think, can you implement it or not. Okay, so this is what we are hopefully we are going to learn, that no matter whether you have coding background or not, zero coding background, still you will able to build AI application. That is the aim. And I don't know whether we will able to achieve it or not, but I'm hopeful that we will. Okay, so we are going to identify a problem, find the best representation and model to solve it, code generation using generative. So we are in this class is not going to write a single line of code, but we are going to write code for everything we learn in the class. So this is the challenge. Okay, so that's we see whether we can do this or not. Okay. So we are going to do the code generation using generative AI to validate the approaches that we learn, and then I'll keep giving you startup ideas. And I'll also be discussing that these are the startups in AI. Today I'll give you 2 ideas about startups and see that how you basically can build startups. And definitely, so I want people who are coming from different organizations to help those organizations developing their AI strategy. So it's important that because the leadership don't understand, okay, they have no appreciation of AI. In India, the AI strategy is led by Modi, by the Prime Minister of India. Okay, so that is the level. Like usually, the AI policies are basically led by the top notch, the top person in the government. So end of the course, we will evaluate whether we met all these learning outcomes or not. Okay, so everybody would be asked whether you think that we met these learning outcomes, and if we would, so then it means that we achieved what we want to from this course. Okay, so 3 broader aspects. One is just learning about AI. Okay, the other is about learning how to develop strategy, how to make strategies and policies, as I mentioned, even for your own self, but for your organization, for your department, and then ultimately for the country. And then about being creative and having startup ideas. And nowadays, almost every country is giving funding if you have a good idea on AI. So almost every country. So you have a good idea, you put a proposal together, you make a prototype, and then you bid for the idea. So you can have AI-based startup, and we'll see that how apparently how easy it is to have an AI-based startup. So these are the prerequisites. This course, as I said, is designed for all, but I still want people to have background in mathematics, because there were some people with masters in English literature. So I said, perhaps you should not take this course. At least you should have some background in mathematics. Mathematics is fundamental, so you should be comfortable with maths. If you're comfortable with maths, and even at least have high school maths, we have an FSC in mathematics, so at least you should have that. But if you have done engineering, computer science, maths, stat, so you should be just fine. Programming only enough for you to know that you are just generating something. So this course is going to explain every concept, every method from ground up. It's recorded on video, so you can listen. I may go fast, but you can then go back and review it as many times as you want to. And code generation and implementation in Python. And course projects. So there will be a course project that will be tailored to match your specialization. Whatever you are, whatever you do, we'll see that we just see the potential, and especially to see the potential to form a startup. So that's also an objective, that at least at the end of the course, in a group, obviously we will have startup ideas and we'll just pitch them here that these are the startup ideas. So, so these are the 3 different types of students that we have in this course. One are just attending, so they just want to attend and they are busy doing other things. So for them, if they want a certificate of that they have attended this course, so they must have a 70% attendance. If it is 69.9, we will not give you a certificate of attendance. Okay, so you got to have 70% of attendance and greater to get this certificate. But I like those who are attending at least to be a participant. So a certificate of participation is that you should have an attendance which is greater than 70%. Then you must submit all the assignments and the term project, and then you need not to appear in the exams. So you get a certificate of participation, and that mentions that you have submitted all the assignments and you have participated in the project, but you don't get a grade, you just get that this is what you have done. But anybody can actually, if you have done all of this, so I'll again motivate people to also sit in the exams. Exam will also be a fun to take exam. It'll be open book, open notes, open internet, open anything, chat GPT. So you just do whatever you have and just do the exam. Okay. So so anybody who gives the exam is going to get a transcript. And if you want to take that course towards any degree that you are doing, even outside Pakistan, so you can get a credit for that too, okay? Because you are going to get a transcript, so we'll give you a transcript which says that you have taken this course and this is your grade in it. So it's better that you earn a grade, and definitely if you want to do your master's or PhD from case, we'll count that. But I'm sure any universities that you are in, you can transfer that credits depending upon their policies, not our policy. So that's something. So this is how we are just splitting the things with assignment 20%, midterm 20%, final 40%, and final project 20%. So this is the way that, so we are going to, so once I say 20%, it means 20% of the time that you got to spend to do this or to prepare for this. Okay, so that's the idea. So these are the people who are going to be. Dr. Ali is sitting here, and I took his current picture. I'm sorry, I know you are even younger than this, but so he is the junior most out of these 3. Okay, so the senior most is Rehan Hamid, and he has a master, and they all have somehow worked with me. Rehan, once we have this enabling technologies, he was part of our team, and then he went to Stanford, did his master and PhD, and then he founded a company named Kinara.ai in Silicon Valley. He raised about $25 or $35 million in venture funding, and he has developed these chip which can do convolutional neural network, deep learning, video analytics in a camera. So you put that chip in the camera. So that's why he calls his company Kinara.ai. And so he has been in this area for so many years. Dr. Yasir Jan is heading our AI department and also our lab. So CARE has a lab, and I'll keep showing you their work also. We have a lab in CASE, which is CARE AI lab. So he's heading that. He has his PhD from Australia, Dr. Ali has from UK. And then there are few other people, because they come and I keep meeting these amazing guys, and all of them they are. Dr. Mukarram, he is heading the BARD, the group which is working on large language model, the infrastructure group in Google. And he has also worked with us. He was part of our team, and then he went to Georgia Tech, did his PhD. And so is Etazaz. He is also heading an AI group in Amazon, and he was here. I met him, so he is also into a leadership position. So we'll see. I have already talked to Rehan, and we will have his lecture, his perspective, sitting in Silicon Valley, how he sees AI. And then I'll be depending upon Dr. Ali and Yasir. Because there's so many students, we'll make sure that once you are into things, then the help is there. The people are there who just would help you out. So then the TAs are Ahmed. You have all been interacting with Ahmed. Then is Munib. He is also a research associate in AI lab. So he is here present all the time and he has been working in this area for last so many years. And Ms. Alia Makbul is a case graduate. He did her master's in 2005 and 6 from case. Then she went to Canada. She did another master's, which is in data analytics, data sciences, and has hands-on experience with Python, with Java, and a very good programmer. And again, she brings another perspective that the companies in Canada, how they are looking at AI. So she will also be there to help you out if you have any query. So we'll be giving you their contacts, maybe their email addresses, so that you can just shoot anything. And we may just partition the class and assign these people so that you have somebody to count on. So now we come to the topic, which is representation that support models. And so we are going to see how data is represented in AI. Okay. So remember the definition of AI. We said it is about solving problems where you requires thinking, perception, and action. And to do that, we said you make models, and for models, you got to have representation, both for the model and for the data. So we are going to cover, and that's why I have colored it differently. We are going to color representation that support models that are targeted at solving problems that requires thinking, perception, and action. Okay? So we are going to learn about that, and then rest of the definition we already know. So today, focus is representing the data, that how you represent the data, the voice, the text, the videos, and the unstructured data. That is also very, very interesting. And today I'll be giving you my personal background into this. And you must listen to this guy, okay, who has given 60 plus years to MIT teaching linear algebra. Okay. So this is his last lecture. Here is the link, and I would like everybody to just click this link and listen to this guy who has, like, for 65 years perhaps, he has taught just one subject, which is linear algebra in MIT. And almost everybody, you know, who is linked with AI, linear algebra, math, so the people know him because all his lectures are on the internet. He's Gilbert Stan. So really has made linear algebra fun to learn. But then he also has published a book which is about how linear algebra is related to AI and deep learning. Right? So that's why it's the dedication for him. This is just I generated from ChatGPT, that matrices in machine learning. Why matrices? Why I'm saying that linear algebra is very important for artificial intelligence. So, and especially once we are dealing with large language models. So why is just linear algebra? What large language model is, mostly it's just linear algebra at its best. Okay, something which we have been studying from our metric class. Okay, so we'll see that. So linear algebra, because once you represent features of a sample, okay, of a patient, of a movie, or anything, of a car, of a person, you know. So you just represent it as, so the sample is a row and features are column. So we'll see a few examples. Because once it is a matrix, that is what you are dealing with, your input is a matrix, okay, or a vector. So all you do is linear operations. You're doing vector matrix multiplication, matrix multiplication, okay, and you are solving linear system of equations. You are just playing with the matrices. So that's why linear algebra is important, and that's why you find that there are libraries, even the MATLAB, for example, does just the matrices. So is Python is very strong. So the GPUs become, you know, effective because everything is in terms of matrices, large vectors. And if you don't know matrices, you can go and open your 10th class book, and that will tell you what matrix is. Okay? This I have taken it from metric book, which says matrix is the arrangement of numbers in the form of rows and columns in a square bracket, and it is called a matrix. Okay? So matrix you can learn from metric books or from FSC books, and that is even enough for you to understand what matrices are. Okay, so order of a matrix is rows into column, And even we know that we use matrices to solve a linear system of equations, that you have 3 equations and 3 unknowns. So you can write them in a matrix form, which is all the constant coefficients of the variable is matrix A. The variables are x, and all these constant on the right are b. So you write it as ax is equal to b, then you take a on the other side and you got to find the inverse, and you multiplied b, and you know all the x if there is a solution. But if these are the 3 lines which are not intersecting at one point, so obviously there is no solution, okay? Or sometimes if there are 3 parallel lines, there is no solution because they never intersect each other. So if the A inverse exists, then it means there is a unique solution. If A inverse does not exist, so there is no solution. If you have more variables than number of equations, there may be many, many solutions, right? So things like that. So data representation, as I mentioned, because it cannot hear, see or sense, inputs are represented as numbers, they are stored in tables or matrices. The row represents a sample or instance, whereas a column represents attributes or features. Okay, so let's see an example. Let's say in AI you want to predict the price of an apartment or price of a plot. Okay, so there are like 2 things important. One is like they have given you the size of different plots and their price. So this is plot number 0. This is the size, this is the price. Plot number 1, this is the size, this is the price. Okay, and now they have another size where you don't have data which says this size plot is this much. But looking at the data you have, okay, you can tell that, okay, if this is the size of the plot, it should be this much using AI. Okay, even the generative AI or just regression, or depending upon what technique you use. But number 1, it is in a matrix, okay, in the data and the rows and the columns, and you just throw them on a graph. You see that there is kind of a pattern. And this is the pattern, this is the model that the AI algorithm will somehow extract and help you to, if you give it a data which is not there in the database, it'll tell you that it should cost this much. Okay, so this is how the data is kind of arranged. This is very interesting, and I want, I'll be discussing a startup idea, because in Pakistan, 60% of the people just deals with plot. That's where we invest our money. Okay, almost everybody. If there is an investment, perhaps the safest investment we find is that you go and invest in a plot. Okay, so this is a publication, and there is also a link here that if you click here, and this is done by people who are into real estate, properties, and this degree. All the authors are actually town planning, or so there are different type of people. And this is a city in, I think, Spain. And here is all it's a seaside, and you see the red means very high price property. And as you are moving away from the city center and from the seaside, or the price of the plot start reducing. And by clicking anywhere, you can actually find out the price of the property. And you see there is a grade. There is something where this prices are changing. You are going from very expensive area to a less expensive area, and they're very, very systematic way, very interesting. This is the map of the area. So you see that anything which is on the seashore is very, very expensive because the seaside. And once you are moving away towards the outskirts of the city, so you get very cheap plot. Right? And then they have, the features are very interesting, that they have to basically estimate the prices. The feature they have is where are the educational centers, where are the green areas, where is the coast. Coast is important. And then they are using GIS and different tools to find out the green areas, the road network, and the conditions. And then even they have incorporated the bridges or tunnels, or and the neighborhood. We say this is a good neighborhood, this is a black neighborhood, this is a white neighborhood, this is a Hispanic neighborhood. So they also incorporated that what type of neighborhood, which is in 150 meter. And even here in Pakistan, we are concerned about the neighborhood. If you're going to develop a house, we are concerned that what type of people live in. So balcony available, view, and so many variables. A very interesting paper. And I think we'll be discussing it towards the end, that we also need something like this, a tool which can just instantly tell you that how good a plot something is, which incorporates almost everything that matters. We don't have, people usually ask, okay, I want this much money for my plot. So there is just asking and what a person can pay, and the prices are just changing because of supply and demand, but not based on some very concrete features that you can feed into the your system. And then you have an application which becomes really important. Still the data points are selling and buying, because you cannot just find out the price of every plot, but then you can see this is what the trade is happening. So you can just create a model, and that model can then basically tell you about the plots which are not sold, which are not for sale even. So and the markets and so many features that you can have. So very interesting paper. The second is the recommender system, and those of us who watch dramas and movies on Netflix, we know it precisely tells you this you are going to watch is like 90% of your taste. This is only 70% of your taste. This is what is trending. This is not trending. This is how much you have watched. So this has been there. A recommender system has been there. You buy a book and it'll say another person who bought this also bought this. The people who are buying this, people who read this are also reading this, and that is what the Facebook and all these tools do. If you are watching something, they'll keep throwing you the same type of content, and they just make sure that you never leave your mobile phone, because they just keep throwing you what you want to watch. Okay, so if you are one perspective, you are, for example, a PTI supporter, you always get what the PTI is good at. If you are a Muslim Noon supporter, you'll find out the content, just throw you that content that basically you want to watch. Okay, because of the recommender system, they can so perfectly model that what you are watching, what do you want to watch, and they just keep throwing you those content, so that and the KPI is that how many hours you spend just watching stupid things on your mobile, because they make sure that you just stick to it, and it is going to improve every other day. They say that you will not able to leave your mobile. They'll just make sure. Okay, but the recommender system is there are different users, they are watching different movies, and they are just giving their scoring to each movie, but then it's very, very intricate. Okay? And this will be my second idea of the startup, which I'll discuss. Very, very intricate. And intricate is that the type of data they feed into the recommender system. This is a genre, like what type of movie or drama it is. Okay, is it action or a comedy or drama or fantasy or horror? And then further to action, there says war and military action, spy and espionage. So they have just so much data for every movie you watch in the background, in the database. Okay, so they know that you watch this type of movie. So they basically, and who are the, and this is about if a thriller, it's a crime thriller or disaster thriller. And then there are other things like who are the stars in it, who are the directors, what year and age you have. So also depends what you watch, and the category and the gender and how this particular thing is ranked otherwise. Okay, so they have so many things, and if you go click here, you will get to this paper. So now it is not a matrix anymore. So though as a user you are watching these many movies, it's a matrix, but then every movie has another dimension. So it becomes a 3-dimensional matrix. Okay, every movie has so many other features, the starring and what type of movie it is and your age and this and that, and you keep building everything which is important, and then it really, really becomes a good recommender system, because now you are making sure. So it works in 2 ways. One is that so they are all the users who are watching, and now they correlate. Okay, this guy has watched something which you have not yet watched, but he watches the same kind of movies which you watch. Okay, so this guy or this girl is watching something which is similar to this, and then he'll just proposing, and they find out that she watched it in 2 days, 16 episodes. So it means she really liked it. She does not even have to say that whether I like it or not. They will know, oh, she's liking it a lot. So they say, oh, watch this as well. Okay, and so watch this as well. Okay, so the other is like you yourself. They say, oh, this is the type of movies you watch or the dramas you watch. And they'll just propose you, okay, because we saw you watch this, so perhaps this is another thing that you should watch, and they'll just, so you don't have to search, ask any of your friends that what type of dramas or movies I should watch. The system will automatically make sure that you watch what you want to watch, okay? And so this is, the recommender system, and we will, and this again a lot of maths in it, okay? The similarity, the cosine similarity, we are going to learn about that. So that's why I said it's just the linear algebra which is working at the back, and so they are all the features, and once you have a feature vector and another feature vector, how do you find similarity between the two? And it's so simple to finding a similarity, okay? So similarity, so we'll cover that in a while. So that's what they find out the similarity. It's math, it's algebra. The similarity is simple algebra. It says, okay, this is the highest similarity to what you like to watch, and I'll say, okay, watch this. Okay. So is the patient record. So everything comes in a matrix. So once you are applying AI, things come in a matrix. Okay. Now let's go for images and videos. We know image is a matrix. Okay, it's like grayscale is given a number, and it goes from 0 to 255. Okay, and so depending on whether it is black or white or what type of gray, so it is assigned a number. So you just sample the space and grayscale. But remember, we as a human can tell this is a motorbike. But see, a computer, what a challenging problem computer is solving. Computer is not shown a motorbike, right? Computer is shown these numbers only. So as a human, is there anybody who can claim by looking at these numbers you can say it's a motorbike? Not possible, right? So this is the most important thing that we must remember, that computer is trying to see things out of these numbers, because computer cannot see. Out of these numbers, it has to say it's a motorbike, which is very, very difficult problem. As a human, no matter how much you trained a human, that looking at these numbers, tell what object it is, okay? For very, very simple objects, nobody could actually able to do this, okay? So computer is solving almost an unimaginably impossible task, looking at the numbers and telling that these numbers are this, right? And that's why people could, by perturbing these numbers a little, can make computer to be confused. And you say, oh, as a human, I can see this is a bird and computer is saying it is an elephant. Why? Because it is scale. An elephant, if it is a little picture and a bird has the same size of a picture, and you play a little with the pixels, a computer may say, oh, this is a bird. Though you can see it's an elephant, and you will be surprised at why it is saying it is bird. Because computer can't see. He has to figure out with these numbers. And and if it is a colored image, then whatever you are developing, you develop basically multiplied by 3. Because you got to split that colored image. Every colored image in a computer is split into 3 parts, R, G, and B. A red part and a green part and a blue part, okay? So once we feed a colored image to an AI algorithm, we are actually feeding 3 images to that algorithm, okay? We are feeding 3 images, not 1. So you feed 3 images. So whatever you are processing, you are doing that processing on every. So we call these channels. So you have a red channel and a green channel and a blue channel. And sometimes you keep these channels till the end. Sometimes you merge them into one. You're just finding out the object, okay? So this is your first assignment, okay? So assignment question number 1. Generate, and I have generated this myself, so it is just so simple. It's very simple to generate a code in Python. So ask ChatGPT to write me a Python code that takes a color image as input and shows the red and green and blue color images, okay? Give your own image, your own picture, okay? And once you ask ChatGPT to do this, okay? Ask ChatGPT to do this. Let's ask ChatGPT to do this, okay? Here is ChatGPT. Hey, ChatGPT, generate me this, okay? Write Python code that takes now it has generated the code, okay? So it has generated the code, and all now you need to do is, it says just replace with path in your computer. So this is where you only give the name of the picture in JPEG and where it is. If it is in your C drive, in your picture, so just give that path. That's it. Copy this whole thing and paste it in, and there are online, like this is Google Labs, so you can just paint it here, or you can paint it here as well. Okay. For example, this is the code which I painted, and this is the picture. This is my picture. I was in Abu Dhabi in the mosque, so with the driver. So I asked somebody to take my picture. So if I do this, I'll just run it, and it's just in 30 seconds, you can actually write a Python code, and it has taken my picture and converted it into 3 channels. Okay. So if I go back to the slide, so this is my original picture. Okay. So this is the mosque, the Grand Mosque in Abu Dhabi. This is the driver who was with me, and it has been split into 3 parts. Okay. So this is question 1 of assignment number 2. That's what you need to do, and you just got to give the right path. Okay. Otherwise, just come back and complain that I'm not finding picture. So you got to just give the right path, and that's it. So and this is the copy of the code, but you generated yourself. As I have shown you, it is so simple to generate. Just generate, put it in Python, and just make it work. And the only error you are going to get is that you are not giving the right path. Otherwise, it'll not. So now we understand that once you have these colored images and you have whatever model you have of neural networks, sometimes it is simply multiplied by 3, because all the 3 channels are to be processed, and sometimes they may be merged. So sometimes they just go through the entire model, and like this is where you do the scene segmentation. And so colors are important, remember, especially in classification. If you're doing classification of fruits out of, or out of these 1000 classes, the colors gives you a lot of ability to distinguish between what type of object it is. Okay? So colors are important, and so we see this is just one example. Now let's come about what is about videos. The video is also matrices. So we have seen image is nothing but a matrix. A colored image is nothing but 3 matrices. Okay? So that's why linear algebra is important, because it's just matrices. Okay? And once you talk about video, it is nothing matrices running here and there. So every time 30 matrices in a second. So you put a matrix, nothing but matrices. Okay? So every matrix has again 3 parts, RGB. So video is a matrix, red, green, blue, red, green, blue, red, green, blue, red, green, blue, and that's what a video is. Okay? But usually the videos are compressed using MPEG algorithm, MPEG-4, and that is very, very intricate and complex algorithm, because it tries to compress things. When it is compressing, what it does, it encode a frame as a JPEG image, complete encoding as a JPEG. Okay, so it gets very little compression because an image is coded as JPEG. But knowing that every frame looks very similar to the previous frame, very little change. Okay, so then it uses that redundancy as well. So once we say a B frame, so a B frame uses all the redundancy, all the things which are there in the previous frame. So that's why the video, you get compression ratios of about 300 times or 400 times, or no matter what, YouTube will make you see things at very, 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 very low data rate as well. Because of that, they can get a lot of compression, because whatever is in this frame, you're going to see almost the same thing in this frame, in this frame. So a B frame it's a bidirectional frame. A B frame uses a forward frame and a backward frame. So that's why there's always going to be a delay. You cannot just transmit a frame once you capture it. You got to wait, because once you get a P frame, which is the predicted frame, so you use a current frame and a future frame to get the maximum compression in the current frame, okay? Because the future frame is going to be similar, and maybe if there is a scene change, a future frame looks more like you, not the previous frame. Okay? So So there are three types of frames in MPEG. One is an iframe, a bidirectional frame, and a predicted frame. Okay, but once you read an MPEG, it converts, and it is not in matrix form. An MPEG and JPEG is not a matrix. Okay, it is a very complex format because it has like micro blocks and motion vectors, and but once you click on an MPEG, it gets converted into matrices. Okay, it's only once you click and there is an MPEG reader, only then it'll convert them back into matrices, and that is what you got to feed into your AI algorithm. You cannot just feed an MPEG-4 video to your AI algorithm. This is important because MPEG-4 is highly compressed representation of the video, which is maybe perhaps 300 times compressed. So it has to be expanded, and then you feed it to an MPEG. So this is your assignment 2, question 2. You generate Python code that takes a video clip in MPEG-4 format and separates its first 10 frames. Okay? Submit your code and the generated frames in your report. So all you have to do is just copy this, go to ChatGPT. Okay? ChatGPT, here's the ChatGPT, ask it to do this for you. If there is an error, you paste the error back to ChatGPT. I'm getting this. You don't need to understand the error, okay? Let ChatGPT to understand the error and tell you are doing this, okay? Or it'll say, sorry, let me just, perhaps I have done this, so let me just generate. So it'll just say sorry and will generate the code again for you. So here is the code, okay? So all you are going to do is just take this code, right? Take this code, paste it again, it'll say just you got to give the right, replace with the path to your input. So just give a path where your actual video is lying. So I did, here is my, so this is the Professor MP4, the video which I showed you in the first lecture. I gave that video and asked ChatGPT to split it into frames. So it has actually splitted that into 10 frames. This is the Professor, and this is what is fed to an AI algorithm, not the MPEG-4. MPEG-4 got to be converted into frames, and the frames are got to be converted into RGB, and those three matrices, okay, and depending upon how many frames do you want to feed to your AI algorithm. So the model is basically taking all of this humongous amount of data once it is doing the video processing, because it's like if it's 24 frames a second, okay, or it is 30 frames a second, or sometimes for some very sophisticated application you may have 1000 frames or 2000 frames a second. People have these type of cameras as well. Especially in cricket, they used to just show these cameras which were taking thousands of frames every second. So I did this, and here are my 10 frames. Okay, so let me show you the 10 frames. This is the code. This is frame number 1, frame number 2. See, same, nothing has changed. Frame number 3, yeah, it moved a little. Frame number 4, it moved a little. Frame number 5, 6, 7, 8, 9, 10. Finish. Okay. So you see that every frame is lot of redundancy because very little is moving once you move from one frame, but you cannot miss that. Because if you miss that, then you see that you will not able to see. But this is what is fed to an AI algorithm. The very first thing you got to do once you're doing video analytics, you got to convert a video stream into frames, every frame into 3 RGB, and those are fed to your model. Okay. So usually there are two types of video processing. One is you say this is 5 second worth of video, and you give that video. So all that entire video has to be converted into data, and data is all the frames which I told you. Okay. So if it is 30 seconds and there are 30 frames, so it is 30 into 30, 900 frames, and if they are color, so 2700 or 1000 or whatever. So those are the number of matrices that you are feeding. That's why AI algorithm requires humongous amount of storage and computational power, because if you are just in a chunk, you are going to feed all this video to an AI. So it has to be converted, the entire data, and then entire data has to go through the model, not frame by frame. It is the entire so many seconds of video goes to the model, and model then makes. So this is an example. It says video classification using AI, where somebody is dancing or waving or shaking hand. And here it says there is a benchmark database which has all these videos, few seconds of video, but the entire few seconds has to be fed to the model. So model is basically trained to have these many number of frames. So you feed all the frames. So you can see the amount of computation the model has to do, humongous, because it is processing everything in parallel, and then finally coming to a decision whether what you have is dancing, waving hand, or the other one is recurrent neural network, which has some memory, and so you are feeding frame by frame. So you feed one frame, then the other frame, and it just keep on just extracting what it needs to from every frame. Okay, so recurrent neural network has been very famous. We'll cover all these topics once we come to them. I'm telling you, the representation is important, and we have seen whether it is a speech. We know is just a vector, and image and video all are matrices. The most interesting is text, right? The most interesting is text, because nowadays this ChatGPT, nobody knows how it works. That's the funniest part of how it is generating the code. Okay, there's nobody sitting there who is generating the code, and it's just amazing to know that how come it can generate such a perfect piece of code. Okay, knowing this, what we are just going to learn. So text representation, how the text works. Okay, so this is a ChatGPT model which says that attention is all matters, and this they use for the translation. That you feed in English, it'll give you French. You feed in Arabic, it'll give you this. But the word embedding also does the same. It converts a sentence into vectors, every word into a vector. Okay, so the very first thing you do, this is amazing. The very first thing you do, you take away the word, its meaning from it, kind of. Okay, so very first block is input embedding. So every word gets converted into a vector. It's just a vector which goes through whole thing and then just start generating something which has meaning. All numbers. No word actually goes into the model. Okay, it's just a vector, and this is going to be your third question in the assignment. That we are going to see whatever word you know, that what is the vector equivalent of that word. Okay. And then you are going to plot that vector in 3-dimensional space. So we'll see that. So now we know that once we say input embedding, it means that every word is converted into a vector, and then linear algebra becomes relevant, because all vectors and matrices, and that's you are multiplying. So nothing but matrices and vectors multiplying. Humongous amount of computation, and just end of the day you are getting another vector, and then you convert that vector into a word, and then you just start writing one word each. So for example, the first step in large language models or the natural language processing is that you have a sentence. I ran 2 miles in the park on Ravi Road. Dr. Ali ran today 2 miles on GT Road. So we were trying to find a connector. So you basically a word I ran to, and this is what you are going to do it yourself today, and you'll be amazed. Okay, just write whatever you want to write, and just convert it into vectors and show you on your 3-dimensional space. It's a fun exercise to do. Okay, so a token means just I ran to my word. So you separate each word. This is the first thing you do, and then you convert them into vectors. So there are always already developed utilities which will take your word and convert it into vectors. And this is where the magic part of the large language model is. The way it converts a word into a vector. And this vector is usually a 300-dimensional vector. a 300-dimensional vector, okay? It's a 300-dimensional vector. Every word converted into a 300-dimensional vector, or 200 or 100, it depends, okay? So you convert them into vectors, and the vectors are that you feed into the model. So it's all vectors playing with each other and just generating another vector, which actually is a word, because a word is a vector, so vector is a word, okay? So this is the way, because people have been doing this, natural language processing people have been doing for years. So this part people have done, in 2016, 2015, 2012, all these things, because whenever you want to process natural language through a computer, you got to convert it into a number, right? So people have been using one-hot encoding. This is the utility, very interesting. It is said word-to-vec, okay, word-to-vec, which uses two techniques. One is continuous bag of words, and the skipgram. Both are very interesting, okay? And as I mentioned, that this is where the magic is. This is where they have done this like way back in like 2015, 2016. And then GLOVE is a Stanford modification into this. And this is global vector for, sorry, not word, word representation. Okay, word, W-O-R-D, word representation. So one-hot encoding is very dumb. It has, like, say, if your dictionary has 10,000 words, so they are going to have for every word a matrix which has 10,000 elements, okay? And one-hot means that every word has a place because there are only 10,000 words. So, for example, the first word you give this location, here is a 1. The second word you give this location, you put a 1 here. The third word you give this 1, 1, 1, 1, 1. So, every word out of this dictionary, so what is the size of a vector? The size of the dictionary, because every word is placed somewhere in that dictionary, and it may be just the index of the word, and there you put a 1. Okay? So every word becomes unique because every word has a place in this 10,000 dimensional vector. But then it becomes so cumbersome that if you have a book and you are processing a book and you have 50,000 words, so every word is converted into 50,000 word vector, and where there is only 1 at one location. So the entire book, if it has 10 million letters, 10 million words, so 10 million words into every word converted into 50,000, so you can just see the amount of data that you are going to process has become. So and there is no intelligence in it. You just putting a 1 just randomly, but you want that words, they relate to other words, okay? And once they relate to other words, you want them to, as they are related, you want to put them in the vector space where they belong, where they relates to other words, okay? So that was the concept of word to vector, and it's not like this that you can humanly sit down and craft the word to vec. Not possible humanly, that you say if it's a living being, so I'll give him good marks. Man, yes, I'll give good marks. Women, given more marks, I don't know why, but but king and queen is again given more marks. So you just have all these features, maybe like we are saying 300 of these features, and for every object you give marks to every feature. It's not possible, but still you want somehow to have these 300 features, but let the algorithm automatically extract it by itself, and you don't know which feature it is actually. So you say, okay, it is unsupervised learning. So unsupervised learning, you say, this is Wikipedia, go find how each word is related to others, and just assign weights so that the words which are coming closer to each other are assigned places which are closer to each other in the vector space, okay? So I'll show you in a while. So this is called word embedding, where every word has a special position in 300 dimensional space according to its occurrence in that data, in the training data with other words, okay? जो उसके रिश्तेदार हैं, उसके साथ वो space में आ रहा है, ठीक है? And how do you find who are the relatives? Because it is unsupervised learning, you even don't know. You just give it text and text of data. And it says, okay, this is who I am, who is here, And this is again who I am, who is here, who is here. This is again I am appearing, who is here, who is here. Okay. So keep seeing where you are appearing and who appears with you, and you try to train. Ultimately, you have this vector. Okay. So the other one is that this is my left, this is my right. Who comes in the center? So I am here, he is here. Who comes in the center? Okay. So two approaches. One is this is who I am, who is along. And the other one is, these are the words who come in. So they just trained this vector, and as I mentioned, the magic is here, and I'll show you the magic, okay? So you convert every word into a vector. So representation of a word is a vector, okay? So this becomes a vector, and the way this thing whole works is that the words which are related to each other, if you see, they will come closer to each other. They will be in this place, and this is, for example, pleasant in a sentence today is a pleasant day, and he is finding out what vector should represent pleasant, and he says, oh, it is pleasant coming with the day or today, and so they have, and the other technique is a skipgram. Skipgram is that these are the words which basically, so I am one of the words which comes with, for example, I sat on a coach, okay? So I sat on a coach, on, it says sat and coach, but sat, it says a word come on, sat, on, I. So it just, with the neighbors, it'll just create this vector, okay? We'll spend more time once we get into the details, but important is the representation. Here is a king, okay, and you can just mention that how many dimension space you want. It says, and we'll see that once you represent, you can say represent in 3-dimensional space. But so there is also another slide which I'll show you that as you increase that dimension, you get more accuracy. More accuracy means the words who are really closer, they get closer to each other. So the king is these numbers, okay. So the king is these numbers, and so here is the relationship between the vector dimension and the accuracy you get, okay. How accurately you could place it with their relatives, okay. So if you are taking 100, so it's not really a good accuracy, but once you go to 300 and 400 dimensional, so you get good accuracy. That words, those who are related, but then your size becomes bigger because every word is now represented by these many numbers, okay. And this is the challenge of large language model. Okay, this is a challenge, and what people are trying, two things. One thing they are trying is to quantize these numbers to 4 bits or 5 bits. Though there are 300 numbers for every word, but then say let's try to quantize. And then they try to make it learn from the data from the entire internet, right? That's what they are trying. And then words, they are related to each other, and then they are how they are just making parameters that they come with these words. So next should be this word, next should be this word, and that's how they start creating things. But so now look at this. So what they have done is they have just colored the value, which could be from minus 1.6 to 1.6, the king and the man. Again, they don't know which feature it is, but it looks similar. The king and the man and the woman. And, G? Sorry, G. So, जी पूछें.
Sir, you the dimensions of terrain, basically these are the features?
These are the features, but you cannot say which feature it is, okay? These are the features, but they are just numbers. But
yeah, I know. How many features we have for one thing? This will make the dimension for that.
Yeah, one feature is one number. So there are, if it's a 300 dimension vector, so there are 300 features.
Okay, we are considering for that thing.
Yes, we are considering every number is a feature. And that's why you see that in every king, man and woman, this value is same. Okay, this value is same, and there are many values, they are same, but then there are values which are different. Okay, so you may able to just guess perhaps this is royalty, so this is human because this is human, and this is animal, this is water, this is metal. So you may able to just guess, but you are not intentionally writing those features as I showed you and making these numbers. So this is just, now look at this. So all this queen, woman, girl, boy, man, king, queen. So these are the values, and the water, which looks very different from Gigi.
Sir, kindly, sir, when you move away from the rostrum, you become inaudible.
यार होना नहीं चाहिए, तो अभी माइक जो है, अच्छा सही है, ओके ओके ओके, ठीक है, सही है, ठीक है, ठीक है, सही है. I know what is happening. अभी I think this mic is not working. This mic is working. Okay, ठीक है, okay. चले ठीक है, सही है. Okay, so the word to vect is like this. So, and again, it is not really linear algebra at its work, but it is trained in a manner that once you say king minus man plus woman, the vector will look very similar to queen. Okay? This is the magic. Okay? This is the magic, that the vectors are trained in a manner that once you do vector algebra on this, it'll start making sense. Right? Start making sense. And once they trained it, they were amazed to see these type of results. Okay? That you from a king vector, you minus the man vector, you add the woman vector, and you get very close to the queen vector. Right? So there is this also, there is a website where you can just experiment. Here it is says this is TensorFlow word to vect. So you see it in 3-dimensional space. Okay. So please remember, it is not a 3-dimensional vector. It is 100 and 200, like it is a 200-dimension vector. Okay. 200-dimension vectors, and there are 10,000 words. It is trained on 10,000. This particular implementation, every word is a 200-dimensional word, and the dictionary size is 10,000. Okay, so there may be a word which is not in the dictionary, and you say, okay, here you say London. Okay, and if you see, it says England, Paris, Edinburgh, Oxford, Boston, Cambridge, York, Dublin. These are its relatives. So they are now closer to this word, right? And it is showing you in the 3-dimensional using the principal component analysis. It has converted them into a 3-dimensional space. This is what we are going to do in an assignment as well, that you first convert them using this word to vec, which has already been developed. So you include this module as a library, and then you give these words and they'll return you the vectors. And then you give these vectors to the PCA, which can reduce the dimensionality to whatever you want the dimension. Obviously, it will not be precise once, because it requires 200 dimensions, and now you are bringing those 200 dimensions back to three dimensions. So it's not going to be exact. What you are going to see is not going to be exact. Why? Because it is a 3-dimensional view of something which is 300 dimension. So don't be surprised if in the 3-dimension you don't see them together. But once you find out their distance in the same dimensionality, you will find this, that only relevant words which are related to each other will be together. Okay. For example, if I say here Monday, so you can just play with this yourself, Monday. Okay. So here is Sunday, Friday, Saturday, morning, evening, week, weekend, day, holiday. That's how it has learned. It has learned that these are the words. So from whatever data it has learned, usually the Monday has come with, and if you say Sunday, let's see what it tells us. If I say Sunday, Sunday, Monday, Saturday, Friday, Easter, morning, evening. Easter is interesting. Okay, so Easter Sunday. So say Sunday. So Sunday evening, Sunday week. So this is how it basically, any word that you give it, here it will show you the words, and here is a representation where it is just showing you all these 10,000 words and you can just click on any, it'll show you the word as well in the three-dimensional vector space. Okay, now if we go back to the lecture, okay, so this is where if you click, you will go to this tool and you can just experiment, just keep giving it different words. There may be words which is not in the dictionary, for example, and there may be words which it really did not find many occurrences of that to be trained accordingly. If say Pakistan, for example, or so it may not have, on the data it is trained, it may not have, many relevance to that word. So, but it does not mean, it only means that it is trained only for 10,000 words. Okay, so that's why it may have like certain limitation on certain words, and it may come back and say this word is not there even in my dictionary. Okay, so but we can do the same for Urdu as well. This is the algorithm that we can use to train it to have, because this is the very fundamental to large language models. Okay, so this is my assignment to you. For a simple sentence, generate Python code that converts all the words in the sentence into vectors, then plot these vectors in 3D space using principal component analysis. Okay, this is the assignment. So let's do this assignment. And the fun part is you can do every assignment in few seconds. Okay, so you go here. So here is the chat GPT and you say, जी वो खुद ही समझ जाएगा सही कह रहा हूँ मैं, ये वर्ड और वर्ड में मैं गपला कर देता हूँ, बट इट विल अंडरस्टैंड कि ये वर्ड नहीं हो सकता. ठीक है, ये देखो सारा फिक्स कर दिया खुद ही. ठीक है, सो इट हैज़ to convert words in a sentence into words. So it has actually a code, and as you can see, it's a principal component analysis, and I think we have it here. So here is the sentence that is like you can write any sentence now, because we ran miles to get to our class, for example. Okay, and then you say so this is OLAP. So I would prefer you to do your assignment on OLAP, and perhaps we will have a session for you, in about an hour session, where we will just tell you that how to use it. Otherwise, it's not really difficult to use this. So these are all the words. Okay, so all the words that I typed, okay, were converted into vectors, and you can see the vectors as well. Okay. And then they are being pasted here in a three-dimensional vector space. So you can see we ran miles to get to our class. Okay, so this is how it has. You can see R, we are kind of put closer together because R and we are related to each other. So important is.
Sir, why it is placed onto different vectors?
This 2
Is the same? Yes.
2 is same as what? No, there are no 2. 2 is there is 1 2 is here. Where is the other 2? I think there is only 1 2. Yeah, it is considering. Yeah, I know there are, because 2 is coming twice, but it has been placed at the same location. Same location पे है 2 ना. Yeah, but in this dictionary 2 is already, it's pre-placed. Okay, this sentence is not making less.